Hey everyone, and welcome! Today we're going to jump right into the world of Docker, a tool that's pretty much changed the game for how we build and run software. If you've ever been curious about what's going on behind the scenes in the world of DevOps and the cloud, then you are definitely in the right place. So I bet we've all been there, right? You spend weeks, maybe months, building something awesome. It works perfectly on your laptop. But then, the second someone else tries to run it, boom, it just breaks. It's that classic, super frustrating, it works on my machine problem. But what if there was a way to guarantee, really guarantee, that your code runs the exact same way everywhere, every single time?
And that, my friends, is exactly where Docker comes in. If you had to boil it down to one sentence, it's this. Docker is a tool that packages an application and all of its dependencies, we're talking libraries, settings, the whole shebang, into a standardized little box called a container. The real magic here is that this container will run identically no matter what machine it's on. Problem solved.
Okay, so let's dig into that a little bit more. This whole idea of portability, why is it such a huge deal? And how does Docker's approach totally flip the script? So this slide shows the classic showdown, virtualization versus containerization. On the left, you've got your traditional virtual machine. To run just one app, it has to pack an entire guest operating system along with it. Think about it. It's like carrying around a whole separate computer just to run a single program. It's clunky, it's slow, but now look at containers on the right. They do something way smarter. They share the host machine's operating system, which makes them insanely lightweight. And what does that mean for you? Well, it means way less wasted resources, startups that are nearly instant, and just a much, much more efficient system all around. All right, so that covers the what and the why, but how does Docker actually do all this stuff? Let's peek under the hood at the Docker engine to really get a feel for the architecture that makes it all tick. The cool thing about Docker's architecture is how simple and elegant it really is. So you've got your machine, which we call the Docker host. On that machine, you have the Docker engine running, and part of that engine is something called a daemon. That's just a fancy word for a background process that manages everything. Now you, the user, you use a client. You type commands like docker run. That client talks to the daemon, tells it what to do, and the daemon is the one that actually builds, runs, and manages your containers. It's a really clean and effective client-server setup. Okay, so let's really nail down what we mean by a container. The best way to think of it is like a perfectly packed, self-sufficient lunchbox for your app. It has your application's code, sure, but it also has every single library, every dependency, and every configuration file it could possibly need to run. Everything is bundled up together in one tidy executable package. Now, what really makes containers a game changer is this idea of isolation. Each container lives in its own little world, so one container can't see or mess with another one. For security and stability, that's a massive win. And don't forget, they don't need a whole clunky operating system like a VM does. They share the host's kernel, and that's the secret to why they're so lightweight and can spin up in like seconds, not minutes.
Okay, this next part is super important to understand. The difference between a Docker image and a Docker container. The absolute best analogy is a blueprint versus an actual house. A Docker image is the blueprint. It's a read-only template with all the instructions for creating your environment. A container, on the other hand, is the actual house you built from that blueprint. It's a live, running instance of the image that you can actually use and interact with. All right, that's enough of the theory for now. Let's get our hands dirty and actually walk through the steps to take a piece of code and magically turn it into a running container. And it all kicks off with a simple text file. It's called, you guessed it, a Dockerfile. Seriously, just think of this file as your recipe. It's just a list of commands that you write down, and Docker follows them step by step to automatically build your application's image. So let's break down what's in this recipe, right? First up, you've got from. This just tells Docker what to use as a starting point, like a fresh version of an operating system. Next is copy, which is pretty straightforward. It moves your code files into the image. Then you have run, which lets you execute commands you need for setup, like installing some software. And finally, there's CMD. This tells the container exactly what command to run the moment it starts up. See? It's just a simple, logical step-by-step process. So once you've written your Docker file, you're going to use just a handful of really key commands to make the magic happen. Docker build takes your Docker file and creates that image blueprint. Docker run fires up a new container from that image. Docker pull and push are how you share your images with the world. And Docker PS is your go-to for seeing what containers are currently running. And just a little pro tip,
These are some of the most frequently asked commands in tech interviews, so they are definitely good ones to know.
Okay, so a single container is awesome, right? But let's be real, most modern applications are a bit more complicated than that. A real-world app isn't just one thing, it's a whole system. You'll probably need a container for your web server, another one for your database, and maybe even another for caching, and they all have to work together.
So, how in the world do you manage all of these different pieces working together? Well, that's where Docker Compose shines. It lets you use a simple configuration file to define your entire multi-container application, your web server, your database, everything. You just lay it all out, and then with one single command, Docker Compose up, your entire system sparks to life, all connected and working together. It's like being the conductor of an orchestra with just the wave of a wand.
All right, let's tie this all together. Why does learning all of this stuff matter so much for you? Because honestly, knowing Docker right now is a total superpower for your career, especially in the cloud and DevOps space. I mean, you look at almost any modern tech practice, and Docker is right there at the center of it. It is absolutely essential for building automated CI/CD pipelines. It is the very foundation of microservices architecture, where big apps are broken down into smaller, containerized services. And it's the gold standard for deploying to a cloud and working with tools like Kubernetes, which helps teams release better software faster. So, I want to be super clear about this. Mastering Docker isn't just a nice-to-have skill on your resume anymore. It's a foundational, absolutely must-have requirement for pretty much any modern role in cloud engineering or DevOps. Wow. Okay, we've covered a ton of ground here, from the core problem that Docker solves, all the way to its architecture and the practical commands that bring it to life. You now have the fundamental knowledge you need to start containerizing your own projects. So really, the only question left to ask is, what will you build first?